So let's start with the keynote speakers. So I'm very delighted to have Bertrand Loy to present. So he's the CEO of Entegris. He's been CEO for Entegris for more than six years. And as some people know, he is a veteran in semiconductors. He's been in this industry for quite some time. And as a track record in the last 6 years, the revenue of Entegris has grown from 600 million to 1.2 billion. So I think he's deserve a very much respect, and is a very impressive result. So it will be very interesting to hear about Entegris business models, how they engage with their customers and suppliers, and how they envision that moving forward. And he will explain how the processes and the organizations and the tools that he have put in place in his organizations to achieve such a very impressive result. So thank you, Bertrand, to have you here.
Good morning. Thank you, Stéphane, for the very kind introduction. Not sure I deserve all of the credit, but anyway, so it's a great pleasure to be here with you today in this wonderful city of Dresden. I'm Bertrand Loy. I'm the CEO of Entegris, and what I've been asked to do today is to talk about some of the emerging trends that are taking place in the semiconductor industries, and really spend the time to talk about the impact of those trends on the semiconductor supply chain. This is the agenda that I will use today to cover this. I will start with a few words on Entegris. I certainly don't want to assume that you are familiar with Entegris. I'll talk then about the fourth industrial revolution. We could spend the entire day on the topic. It's actually very, very exciting. But I promise I will limit my comments to what it means for the semiconductor industry, and then in turn what it means for the semiconductor supply chain. And instead of doing that in very generic terms, I thought I would actually spend time to share with you our own experience of both the challenges as well as the opportunities that we are seeing through, as we embark into this digital transformation. So let's start with a few words on Entegris. We were founded just a little over 50 years ago. We are headquartered just outside of Boston in the US. In terms of the size of the company, we have about 4,000 employees. About half of them are based outside of the US, mostly in Asia. Revenue-wise, today I'm knocking on wood, but if everything goes well, we should be approaching 1.5 billion this year. And with that level of revenue, believe it or not, I know a lot of you are part of much larger companies, but with 1.5 billion, this would make Entegris the largest independently traded specialty chemical company with a focus on the electronics industry. So in order to maintain our leadership in the three big product franchises that you see here, we have actually chemicals and materials. We have another division focusing on filtration and purification solutions, and the third division would actually develop products for ultra-pure packaging solutions and other fluid handling solutions. But to maintain our product leadership and technology leadership, we spend about 8% of our revenue every year in R&D. And for some of you, it may look low. For others, it may look high, depending on the industry you're serving. I would tell you that as a specialty chemical company, this is a high number. I'm being asked by my investors regularly to justify that level of spending, which we do because we're growing. So as long as we're growing, it's okay. But we are spending about 8% in R&D every year. So I think you get it. Entegris is a process solution provider. Those solutions can take many different shapes and forms, but all divisions of Entegris have one common mission, and it is to improve the productivity of our customers and or to improve the performance of their products. And we tend to focus on some of the most demanding manufacturing processes in the world. And when you think about process complexity, I know that many of you are in the semiconductor industry. You probably will agree with me that the semiconductor industry is in a league of its own. So no surprise, most of what we do actually ends up in the semiconductor manufacturing process. But we serve other industries like life science and other industrial applications as well. So again, I would say that today it's a great time to be in the semiconductor industry. And for those of you who have been in this industry for long enough, you probably will agree with me that it was not always the case. The last couple of decades, we've gone through a pretty dreadful roller coaster. But right now, it feels much better. It's been feeling actually much better for the last 2-3 years. So the question is, why is it better now? What is different today versus what we've experienced for the previous 2 decades? And I think that, in one word, I think it really has to do with the very beginning of what many people call the fourth industrial revolution. It's a term that Klaus Schwab introduced at the World Forum last year. And his hypothesis is that there will be a convergence of technologies that will fuse the physical, the digital, and the biological worlds in a way that it will really transform and redefine our lives in a very fundamental way. So we could spend the day on this. I won't. If you look at it from the semiconductor industry, this fourth industrial revolution really feels like a data revolution. And I'm sure that many of you are familiar with all of the statistics here on the left side of the slide. We are seeing certainly an explosion of data. 90% of the world data today was created in the past 2 years. I think you've heard that stats before. Google is estimating that once autonomous driving becomes a reality, those cars will generate 4 terabytes of data every day. To put that in perspective, this 4 terabytes of data represents about twice the amount of data contained in the printed collection of the Berlin State Library. And those cars will generate that amount of data every day. So an explosion of data. And if you think about it, a lot of the applications that will ultimately define the fourth industrial revolution is about data, whether it's personalized medicine, whether it's smart cities, autonomous driving. It's all about moving data from the edge of the network onto a server to store the data, index it, correlate it, and then process it in a way that you create new intelligence, new value, new insight for the user, and you produce that insight back to the user. So again, I think that this fourth industrial revolution will have many great applications. I'm really excited about that. I think it will shape and reshape our lives for the better. So great reason to be excited about it. When you are in the semiconductor industry, there is another reason to be excited about it, is that the fourth industrial revolution will create the conditions for an explosion in semiconductor demand. And if you look at the 9 megatrends across, those 9 megatrends will create an additional $100 billion worth of IC demand in 3 years from now. And that will represent about 90% of the growth of this industry over the next 3 years. So of course, PCs and mobile phones and other mobile devices will continue to be the majority or drive the majority of the demand for semiconductors in 3 years from today. But again, they will not grow all that much. So again, overall, a lot of reasons to be excited in this industry. First, I think that we will see growth of about twice the rate of GDP for the many years to come. So that's one good reason. The other good reason is I think that as we see the emergence of a number of new drivers, when we see the multiplicity of those drivers, it will also bring more stability to the industry. And that is good as well. So I'm actually very excited about what's coming ahead of us. But So exciting on the one hand, but we have a lot of work ahead of us. And I would argue that we need to really rethink entirely the IT infrastructure. And I'm not only talking about 5G and the promise of better latency and instantaneous computing. I'm really talking about every single component of the infrastructure. We all know that there will be a lot more sensors everywhere, in cars and buildings and everywhere. And we need those sensors to be a lot more energy efficient. We need, of course, those sensors to be a lot more reliable. We need a lot better storage technology. I was talking about the explosion of data. Estimates would suggest that by 2022, the world will generate about 10 zettabytes of data. This year, the estimate is for 2 zettabytes of data. So in other words, 5 times as much data will be generated in 4 years from now. So we need a massive amount of storage, better storage capabilities. And when you think about how in the past the industry has developed chips of greater performance, it was all about Moore's Law. It was all about miniaturization. And I would argue that we're kind of running, this recipe is kind of running out of steam. And the industry will have to come with new tricks. And those new tricks will be a combination of new chip designs. It will also be about the introduction of new materials with better electrical properties. So to make my point, I want to use maybe the example of the 3D NAND architecture, which is the newest architecture in memory land. And when you think about this, in its simplest form, I would say that when you think about building the tallest structure in the world, like the Burj Khalifa in Dubai, you will quickly realize that you're going to need to think about your construction in a different way than if you are just thinking about building a 4-story building. You will also quickly realize that the materials that you're using won't probably be adequate for a structure that has a 6:1 aspect ratio. And I would say that the same logic is actually true for semiconductor manufacturing. Today, some of the leading memory makers are making devices with 64 layers, and we are actively working with them to enable 96 layers and hopefully tomorrow 128 layers. But what it means is that those structures have or will have a 50:1 or higher aspect ratios. And needless to say that when it comes to those very narrow and deep trenches or channel holes, you need perfect structural conformity, and it's really, really hard to achieve. You also need to worry about this very delicate staircase structure that will actually condition the read and write performance of your device. So, but instead of putting drawings in front of you, because drawings are easy to draw, I wanted to put a picture, because the picture shows you that those structures actually exist. And they are actually very, very complex. And the title of this slide actually says it all. You have actually challenges everywhere as you continue to stack up. It's extremely hard, as you can imagine, to etch in a continuous and uniform way up and down those various stacks of silicon oxide and silicon nitride. You also, in that process, you're going to need to either modify the materials, or you're going to, in some cases, need to choose to change the material. The same challenge is true for those, silicon channels, where the performance of your device will be limited by how well your electrons will actually be able to travel up and down the channel. So you need to think about new doping solutions to actually preserve the uniformity of the performance up and down the channel. The staircase is also a problem, because you're going to need actually some conductor material that would run the length of the staircase, and the staircase length is actually growing as you add layers. So the industry is also considering moving away from tungsten, which has been used for decades, and considering embracing cobalt or ruthenium or other materials with lower resistivity in an attempt to improve the performance of the device. So challenges everywhere, new materials everywhere, great integration challenges. So on the one hand, very complex. On the other hand, a lot of promises. Purity is also becoming more of a challenge. So purity is increasingly important, yet it's also increasingly hard to achieve. Purity, of course, defines your yields. And as you can see here, the numbers speak for themselves. 1 point of yield can represent a lot of money in an advanced fab. And many of you know that. I know, painfully aware of it, probably. Yet, purity is also important for a number of other reasons. The purity of your conductor material will define the speed of your device. The cleanliness and the purity of your dielectric material will also condition how much energy leaks you have and how much energy efficiency as a result your device will have. And then increasingly, actually, this is probably something new here, but with the industry now becoming more focused on medical application, automotive applications, the reliability of the chips is becoming actually more of a focus. And the industry is not just concerned about contaminants that can create a killer defect, but they are increasingly concerned about very, very small contaminants that could, over time, compromise the long-term reliability of the chips. So in other words, latent defects. So purity is very, very important and becoming more important, yet it's extremely hard to achieve. You were talking about atomic level contamination control. So to put that in perspective, if you think about the cleaning steps in an advanced logic fab, today the tolerance would be for, if you think about contaminants of 16 nanometer in size, only 4 of them would be allowed after a cleaning step. So put that in perspective, it's as if Germany would be covered with €1 coins, covered with coins everywhere, and one clean sweep, you need to remove every single coins but 10, maybe trapped in Schwarzwald or Bavarian Alps somewhere. But that's the amount of tolerance that we are being asked to deal with. And we know that those tolerances will probably continue to be more stringent as feature sizes continue to shrink and as those structures continue to rise. So a lot of challenges, and I mentioned many of them already. And if you think about it from the standpoint of a supplier to the semiconductor industry, it means that our world is actually changing radically. Gone are the days when it was good enough to ship to spec. Today, most of our products will have to be shipped to control. And our process windows are just becoming tighter and tighter. We also realized, several years back that we needed to take greater control of our own supply chain. So we needed to have an early fingerprinting of most of the materials that are used in, as input materials in our products. And the same logic is true for purity levels. It's, we had to invest a lot to make our own manufacturing processes a lot cleaner, but increasingly we're now working with our own suppliers and their suppliers to increase, the level of requirements in terms of purity. And of course, we need to introduce new transportation standards to preserve the cleanliness and also the stability and, needless to say, the safety of all of those chemistries as they travel very complex supply chains. So when you think about all of that, so a lot of challenges, but I like to see opportunities in every challenge. And at Entegris, we saw the emergence of those new requirements about 10 years ago. And as a result of a number of internal developments, as well as targeted acquisitions, we have developed a portfolio of capabilities that put us in a unique position to help the ecosystem solve a lot of those process challenges. So we have 3 divisions. The first one is really around specialty chemicals and advanced materials. Sorry about that. And you can see, we have capabilities to synthesize new molecules for some of those deposition materials, dopants, formulated cleans, etc. We have another division around filters and purifiers for liquids and gases, and then the third division is really around ultra-pure packaging solutions, as well as a number of comprehensive fluid handling solutions to manage and deliver liquid chemistries. And what we do is we actually offer those solutions in a discrete way to our customers, but increasingly as we collaborate with them, they want us really to co-optimize chemistry and best-known methods of filtration, or chemistry and the perfect match in terms of ultra-pure packaging solution. And in some cases, they even want us to actually combine all of that into a system solution. So how do we do that? Well, we collaborate. I'm a big believer, we are big believers at Entegris in open innovation. Frankly, the process challenges that we are being asked to help solve are so complex that without collaboration, we would not be able to do that. And this actually little cartoon here is our customer engagement model. And it's essentially the experience, the customer experience that we really want to provide to our customers from the very early development stage all the way to high volume manufacturing. And it sounds really easy and simple, and it is at some level, but it's a little bit like golf. I'm not a golfer, but every so often I decide to try again, and how hard can it be? You have a little white ball, you put the ball on the ground, you take the stick and you hit it, and it needs to get in the holes. That should be simple. And usually after 2 or 3 rounds, I just stop. It's just frustrating. And the same is true here. It's golf like this requires a lot of focus, a lot of commitment, a lot of skill, a lot of practice. And I would tell you that this model is simple, but it's been a strategic compass for Entegris. We always look back to this to define where we need to make our next investment and how well we are comparing against our competitors. And more than a business model, I've come to realize that it's really actually a mindset. And it's really defining the type of people we want in our teams, the type of behaviors we will not accept within the company. So when it comes to defining where to invest, this model actually forced us to think about our value proposition and to boil it down to 3 major elements. And the first one is technology. And it's clear that without a differentiated technology, frankly, you don't have anything to contribute. You will not be invited to solve the next process challenge. So you need leadership position in your technology portfolio. But you also need the global infrastructure. We want to be an extension of the engineering teams of our customers, which means that we need to make it easy for them to partner with us. And then finally, we need operational excellence, because it doesn't matter how good the technology is, if we cannot make it in a repeatable way and in a stable way, our technology is worth nothing. So when I became Chief Operating Officer that was late 2008, I spent a lot of time meeting with our customers and asking them, how is Entegris doing as a partner? And I would say that the feedback was mixed, and that's probably an understatement. It was, when you are new in your job and you get asked for customer feedback, the feedback is not very good. That's sobering. And that was a little bit the case. And we actually took it to heart and we tried to improve. So on technology, the feedback was, you're a good technology provider, but too often you just work on sustaining projects. You don't really take risks. You're not willing to really commit to something, a little bit different from what you're doing. So as a result, we decided to increase our R&D spending from 5% of revenue to actually at some point in time, 10% of revenue. So today it's 8 to 9. And that actually has helped us tremendously be relevant on the technology roadmap of our customers. Global infrastructure, we were very much US-centric, so we had good feedback from US customers, but frankly, our Korean and Taiwanese customers, we were just absent and missing in action. So We spend a lot of money to build tech centers, to invest in advanced metrology capabilities. Back 10 years ago, we were spending about 3% of our revenue in CapEx every year. Today, we spend 7%. So in order of magnitude, we're spending $20 million every year. Today, we spend in excess of $100 million every year, most of which really in tech centers, analytical capabilities, and then, of course, manufacturing capabilities. And that leads me to the last one, which is operational excellence, which is really where we had the worst rating. Our customers were really not happy with our quality performance. Now, I will share you some data around our journey here, but if you look at where we started, well, their feedback and their assessment was very fair. We wanted to be a trusted partner. We wanted to be a world-class manufacturer. Well, back in 2010, we were not. And those are, so DPPM metrics, so it's defective products returned by customers. We, of course, have similar type of tracking for first-pass yields, et cetera, but I can't show that to you. You would see the same progress, though. But if you think about it, so barely 4 sigma. So before 2010, it's not that I don't want to share the data, but believe it or not, we were not even tracking it. Or we were tracking it, but the methodology was not consistent across the plants. But our estimate is that by, in 2005, we had about 35,000 DPPM. So again, totally unacceptable and really shameful at many levels. So we had to change. And we had to change very radically, and we had to change very quickly if we wanted to be credible. And that's what we did. So we started tracking for the first time. We had a baseline in 2010, and then we focused on it. And I'm pleased to say that the focus paid off. And we've seen some steady improvement year after year after year. I would tell you that in 2011, when we set the target, we said, we don't know how we're going to get it, but by 2015, we want to be at 200 DPPM. And at the time, we had no idea how we would actually do that. But we knew that we needed to be close to 5 sigma, otherwise we'd have no credibility whatsoever. So you can see steady progress. In 2014, we acquired a company called ATMI, which was about half our size. They didn't have the same focus on quality, so we took a little bit of a step back. But again, we continued our progress after that. So how did we do that? Well, I would tell you it was really a massive undertaking. It really required total retooling of our systems, of our processes, but also our organization. And I would tell you also that when we started this journey, we were about a $600 million company. We had very limited capabilities and means, and I want to take a moment to thank the camLine team for being a great partner through this journey. And I'm not just talking about the software. Actually, I'm more thankful for the support of your global teams around the world throughout the journey. And that made actually a huge difference for us. But so we started in 2011 in Malaysia. So why Malaysia? First, we had a really good business reason. We were launching a new product platform, very critical platform for Entegris, our next generation process carrier. We call them FOUP. They are those boxes that would transport the in-process wafers in many fabs. And that's actually a flagship product for Entegris. We had 50% market share for that product. We wanted to increase, but this new generation of product was very complex. And frankly, we were struggling and we're getting close to introducing the product. We were not sure we knew exactly how to make it repeatedly. So we needed real-time statistical process control now. And that product is made in Malaysia. The other reason we picked Malaysia was that this was the only place in the company where we had statistical process control knowledge. And and the reason was that the data storage industry was in the process of moving a lot of their manufacturing out of Malaysia into Taiwan. And they were leaving behind a lot of great talent. So we have Eliza Chin here, and many of her colleagues came to us. So that was the loss of those guys. That was our gain. And without Eliza and that team, we would have never been able to do that. So we did it in Kulim, in Malaysia. We did it really, really well, very fast. That product line that I was describing actually was a huge success. It was a rocky start, but we actually, a few years later, we were enjoying a 75% market share. So we went from 50% market share to 75% market share. That would have not been possible without the investment in space. And then we didn't stop. For the next 3 years, we moved all of our global sites to space. We also added the QS system and customer quality system as well. We then moved our focus to the recently acquired sites of ATMI, and that by 16, essentially, we had every site on space. We had the supplier dashboard and the customer quality system in place. And since then, we continue to invest. SQM, we have invested now in local architectures to improve the performance of the system. So today, I would argue that we have all of the right system capabilities in place. We are a small company versus many of you, but I would say that the scope of our project is actually pretty significant. We have close to 2,000 users. We have, over 30,000 part numbers covered by the system, and close to 20 sites on a global basis. And now we have a very nice tie-in from early characterization of raw material into our WIP, into our process data, into our product data, and we can now routinely ship our products with the right C of A attached. Actually, close to 10,000 of our products going to over 200 customers daily are shipped with the right C of A. So was it easy? No. Was it quick? No. And always want it faster, Lisa. It's no assessment. Was it popular? No, it wasn't. We organized it by 3 divisions, which is really good at one level, but each of these guys actually run their manufacturing independently. We actually have many, many different types of products. That means we have batch processes for chemistries. We have discrete assembly for our electromechanical platforms. And frankly, our level of statistical process control knowledge, or just applied stats in general, was just not existent, with the exception of Kulim. So a lot of resistance. So if I look back, so we had a lot of challenges, but what is it that we did right that made actually this project a success? And I can think of a few things. First, we made that project very, very visible. And when I moved from the chief operating officer to the chief executive officer, actually I kept the quality organization reporting to me directly. It was not just because I wanted to send a signal, but I was really worried that this program would actually not get the right level of visibility, and I think that made a difference. The other big thing is that Eliza, after her success in Malaysia, actually we asked her to run this program worldwide. We needed to set standards, and we needed somebody to define those standards. Eliza also commissioned a number of teams in all of our sites. It was important because, again, we didn't have pre-existing statistical knowledge in most of our sites, so we needed help to get up and running and do a lot of the statistical analysis as we started collecting data. But of course, I really wanted, fundamentally, our principle as we run our plants is we want the cells to own their data, to use their data. So we decided to train, and it was a massive effort, it still is, to really train all of our manufacturing engineers, our quality engineers. I would be honest with you, I would say that probably half of them didn't make it, and we really had to change. And we brought a lot of people coming from our fab customers that had pre-existing experience. And then the last thing we did is we really wanted to put our money where it mattered. And we made actually improvement in quality metrics are compensable goals. So at Entegris, we have 10 goals every year that defines our bonus for everybody from shop floor all the way to me. And the improvement in our DPPM metrics was conditioning 20% of our bonus every year. So that made it clear to everyone that we really meant business. Now, in spite of all of that focus, there were so many reasons this thing could have gone wrong. And I would tell you, we were overwhelmed at the beginning with the amount of data, and it took us a lot of time to really force people to really only look at the critical charts, force the correlation between key input variable and key output variable, and all of that. And then once we had done that, then for the critical charts, really force everybody to put control limits and then use that. And then, of course, the scope creep. Everybody wants to move to the next module that camLine is nicely presenting, but we wanted to really ask people to take the time to just do the hard work first. So in summary, I would say that, are we there yet? Well, no, but we also know that, it's a never-ending journey. We know that the expectations of our customers will continue to improve, will continue to increase, will continue to be, harder to reach. What we want to do at Entegris is really offer a statistically empowered supply chain to our customers. And what it really means is that we need to now start working with our own supply chain, ask them to do early characterization of their raw materials, ask them to really introduce statistical process control in all of the critical parts and products we buy from them. And that's a massive undertaking. It's a system commitment. We have also invested in an organization that can actually assist do that. And then, of course, we'll continue to be also very centered around our own, environment. And we have defined maturity metrics. So we want to be sure that all of our products really now are subject to the same expectations in terms of having control limits, tightening of control limits over time when it makes sense. And then when the time is right, then I think we'll try to tie it all together around a manufacturing execution system. So, and this is my last slide. I know I get the time indication, I need to rush. So the last slide is I will just say that, when I look back 10 years ago, I was spending a lot of time apologizing to our customers for our quality deficiencies. And there were a lot of apologies. I don't have to do that anymore. And that makes me feel really, really good. And a lot of that is thanks to people like Elisa and others in the team. So instead of apologizing, now when I meet with customers, we talk about the future. And we talk all of the new things we could do for them. And it's a great feeling because I know that our value proposition is actually real. We have the technology, we have the global infrastructure, and we have the operational excellence. And that makes me actually really, really happy. So that's my last slide. Thank you all.
So thank you. Hello. Yeah, thank you very much, Bertrand, for the presentation. So I will now maybe take 5 minutes to have some questions about the presentations, and if you have anything about. Yep. So maybe just take the microphones and hand over to this gentleman from Global Foundry. I just the. Okay. Yep. Give it.
Okay, now it works. Okay, thanks. So Andre Höfer from Global Foundry. So a question I would have is, when you were really driving the SPC programs and the quality improvements, for example, what you were mentioning, going from KOV to KIV, going to really critical charts, yeah, which methods did you use? Which kind of ways did you use to kind of really figure out what is really critical, really critical, really critical? What role did FMEA play in that? So kind of can you maybe elaborate a little bit on that?
Yeah, so
It's on.
Okay, yeah. So I probably will require, if you want, a very detailed answer. I think you should really ask Elisa to give you the secret sauce. But just to put that in perspective, I think that at some point in time, I remember shortly after we started in Malaysia, I went to visit, and I realized that we had generated so much information. We had about 700,000 shots, and people just didn't know what to do with it. So that's really where we decided to really invest into a team of experts. We kind of took the Six Sigma team away from their any Six Sigma projects. They were some of the people with the most advanced statistical capabilities, and we really asked them to help the team comb through all of the information we were gathering to actually whittle it down to 7 to 10 critical shots, really focusing and trying to eliminate the focus on output variables, but really try to actually focus on the input variables. I would tell you it wasn't necessarily easy, because we also realized that we didn't really necessarily have all of the right metrology capabilities. We were not necessarily measuring everything that we needed to measure on the output. So again, I think Elisa, maybe during the break, can give you exactly more details about how actually she managed to put it together. But it was a staggering amount of work indeed.
Other questions from the audience, or maybe one question to Bertrand. So the program and the journey that you have taken is very impressive. And what do you have done differently, looking at this program? If you have done something different, okay, can you?
Yeah, I think that I probably would have made a bigger investment in training and a bigger investment in bringing on board, statisticians in the organization. I think we were very well intentioned with the training. I think it took us too long to try our hardest and realize that the organization, or parts of the organization, would not be able to actually, live up to the new standards that we had in mind. So we had to make changes. I think we probably deferred some of those changes for a little bit too long. And that's what I've done differently. But remember that when we started the project in 2010, 2011, we're all also recovering from a nasty downturn. So it's always difficult to invest in advance of your needs. But right. If I had to do it again, that's what I would do.
Yeah, I share the point. Is we always underestimate the amount of training and about when you have a change of processes like that. The tool is not only the only thing.
Well, the other thing is, even if you actually start narrowing the focus to some fewer critical shots, you still then need to do the work on setting the control limits. And that, if you get it wrong, the financial penalty can be very, very significant. So having an organization that can really look at those trade-offs, set those control limits in a way that is acceptable with a view of over time owning actually a tightening of the process window, is something that is hard to accomplish. But so again, that's why it takes time, but that's why it also requires focus. Without that, I think you're not going to get the value.
Yeah. So I'm sure for the next program for UMES, the lesson will be learned.
That's right. Well, I think we have a much better team now. I hope you would agree with that.
I hope so. Yeah. Okay, great. Thank you, Bertrand, for your time. We really appreciate it. Thank you. Thank you.